Oh, whoops. Wait. So if you want, I can just show you. I can walk you through one.
Yeah, let's do number one. Just kinda...
So let me just open up Paint.
Okay.
Let me flip my camera. How did I do that? Okay, so that's my screen.
Okay.
This is really obnoxious. So we're looking for the margin of error, right?
Right at 90%.
So we'll just grab this right here. So the margin of error, Z. Oh, it's kind of small. I can't read it. Z plus that.
Okay.
Divided by the sample size. Okay, so we know Z, if you go to this table right here, that was in the reading.
So it's like 1.65.
Yes. So we'll go over here, 1.645 plus the standard deviation of 50 divided by the square root of 25. So I like to do this first because of order of operations. I think that's important. So if you do 50, all right, here's my calculator. What the heck? 50 divided by the square root of 25. That gives you 10. And it's, does it say plus? No, it's times. You see how this says plus? That's supposed to be times, my bad.
Oh, okay.
It's 10 times 1.645.
Okay.
So for that, I got 16.45, for example.
Okay, so you do the z-score times the I forgot what it's called. Or whatever that symbol is.
Deviation?
Yeah, over
The,
so you do
the sample size.
the
Square root
standard
of
deviation
size.
over the sample size.
Yeah.
So z-score
It
times
says 3 decimal places. So maybe that's not the right answer because it only goes to 2 decimal places.
Let me see. Sorry, I'm looking at the book right now. Just so I can know where the formulas are at. Because I don't think it has to go 3 decimal places if there isn't 3 decimal places.
I don't know why I would ask for 3 decimal places though.
Right.
That's why I'm a little confused.
Yeah.
But if that's not it, I don't know how I'm doing it wrong.
Yeah, I'm trying to find the equation on the book, see how it's written out.
Let me pull it up for you.
Okay, yeah. I'm not seeing it.
I think it should be 3.3.
3.3.
Yeah.
So how'd you do it differently? You just multiply the z-score first and then divide it?
I divided the standard deviation by the sample size first. Because I think that's what you're supposed to do with the order of operations.
Right. Well, I think it depends on how the equation is. Because if it's z times the standard deviation divided by like if
Okay,
it's that if
here it
that's
is.
like paired over, then you run to the top first.
Here it is in the book or the reading.
Oh, okay, yeah. So you don't want to divide it first.
So does that look like I did it right?
Yeah, I think you did right. That's
Okay,
all
then
good.
let's move on to the next one.
You said 16.453.
I said, let me go back to it. 16.45. Did you get 453?
Oh no, I thought that's what you said was like 0.3 or something like that.
Oh, it says round to 3 decimal places.
I
But I
think it's
didn't get
probably
3.
just like a standard like
Okay.
copy paste something, not
Yeah.
like not for every single question.
Yep. Okay, let's go to the next one. Which of the following statements is true? So the standard deviation squared is an interval estimator of is that symbol the mean? Yeah, that's the mean.
The X?
Yeah, that's the mean.
Oh, okay. For some reason, I was thinking that was the sample size. The sample size is N.
Yes. Or the mean
The
is an
mean is the U, right?
estimator of the population parameter. I think that's the answer.
Number two.
Yeah.
That's what I was thinking.
All right, we can do that because we can check twice.
Yeah, hopefully we can get it right in two guesses.
Okay. Gina wants to construct a 95% confidence interval for GMAT scores. She knows the standard deviation is 113. She collects a simple sample of size N64, computes X equals. Do you know the formula for this one?
I'm trying to pull it up right now. I'm not 100% sure what formula it is. So this isn't the same thing as the one before it, right?
No. So the point estimate, I think that is. Well, that should be the mean, but they don't give us the mean, do they?
No, it's
So we have to find the mean.
so what is the 526 they're giving us? That is the
Let's see. I'll give you the equation.
yeah, I'm just struggling to figure out what that X means.
Okay.
So let me see here.
So that's to get the. This is the confidence interval formula.
Oh, okay, so you're saying it. Let me see. That's one where you're trying to find it between the two numbers, right? In between the two values.
Yes.
Oh, okay.
So basically, we need to know the middle point.
Okay, so you don't know the point between the two.
Yeah. Um. Let's see.
Sorry, kind of cold.
I also got another formula if you want to see that.
Okay.
So you just have them all.
Yeah, let me look at that one really quick.
So this next one is the sample size required formula.
Okay, I have not seen anything. I'm just seeing the blue.
Yeah, give me 1 second.
Oh, okay.
Writing it down for you.
All right. I was like, this is not right. Okay.
So this is a sample. The sample size required formula. Can you see that?
Yes, that's n equals z plus standard deviation over what's the bottom part?
M squared.
M is the mean.
I'm not sure. I wasn't exactly sure on that one. I think it is. I think it's the margin of error.
Oh, okay.
Yeah, pretty sure it's the margin of error. Let's see. Are there any other ones that you would need? I think you're good with those three.
Okay.
So for this question, so I think the margin of error. She wants to construct a 95% confidence interval for GMAT score. She knows the standard deviation is 113. She collects a simple random size of N64 and computes. Wait. What are we doing? It says that the mean is 526. So the answer is 526.
Wait, is that the answer?
Yeah, I think so. I believe so.
Okay. So why would it be five? Why is it just 526?
So,
Just because that's what the mean is. So that's what
what
she's
the
predicting.
point of estimation is?
Yeah, so you want to try to predict what? Um.
So there's an example from the book where it says using like a political race. So it gave the idea, it said that Republicans are 49% likely to win the presidential nomination, right? So
Right.
that's the point of estimation. And then it gives an interval to um, to like the possibilities of what it could actually be. It's like a 3% interval. So that could go from 46% to 52%. And then
Right.
it gives you the confidence in between those two different numbers. So basically, it's just the number in between. In this case, it would be the mean.
Okay.
But we'll see if I'm wrong.
Yeah.
We'll go back if that's not right.
No, that makes sense because if she's trying to predict what it is, why wouldn't it be the mean?
All right. What is the margin of error for the 95% confidence interval for the true GMAT score? Okay, so do you have all the formulas you need now? Did you write them down?
So I just don't know which one to use.
So it's asking for the confidence interval. So you're going to use the confidence interval formula, this one.
Sorry, let me
It
pull
gives
it.
you the window
So the first one.
where my finger is.
Right. Okay.
So let's both do it and see if we get the same answer.
Okay,
So 95% confidence your z value is going to be 1.645.
Yeah, can you show me those values again, or I can?
So you can write them down.
Yeah, I'm trying to find it. Like, I think the book is just a bunch of formulas. And it's hard to figure out what goes to what. Actually, give me 1 second.
Can you see it?
Yeah.
I was writing it in a car, so it's a little sloppy.
Oh, yeah, totally fine.
And you know what alpha is, right? It's basically just turning the percentage into a decimal form.
Okay.
So this is basically just converting this into a decimal form, and this is the z-score.
Oh, okay. Yeah, so it was 1.645. Then what was the other two? Sorry, I lost one straight down.
95% is 1.96.
And then 2.58.
And 2.58 for 99.
Okay.
Okay.
All right, so the x,
So that's the mean.
the x is the line over. That's the mean. Okay.
And once again, I think you have to divide 113 by the square root of 64 before you times it, or do anything else.
Right.
Or you might run into some problems.
Okay, I'm not sure if I did this right.
Me neither. What is the margin of error? Oh, wait. We're not using the whole formula. So it would just be...
Oh, so this answer does not make sense.
So the z is 1.113 divided by the square root of 64. Oh, my calculator's about to die.
All right, so 113 divided by 8.
I got 27.685.
For the answer?
Yeah.
So, how did you get it? So, did you do the 526 minus the 1 point?
No. That's the window. You need the margin of error.
Oh, okay.
Which is this right here.
All right, yeah, I was using the wrong one. So you just do the z-score times. You don't use the mean at all.
No.
All right. Yeah, one more time.
My phone's gonna. Not only is my calculator gonna die, my phone's gonna die. I hope that's right. 27.685. And you're supposed to round
that's
to
right.
right?
I believe so. It doesn't say, but that's usually what I just default.
So what is the lower limit? So you would do 526 minus 27.685. And that should give you the lower portion.
Oh, okay. And then the higher portion would just be 526 plus the 27.65.685.
So I got 498.315. And then the upper portion is 526 plus 27.685.
Oh, that's not like super slow typer.
Okay. Question 9 asks, what would happen to the width of the confidence interval if Gina increased the sample size? What would happen to the width of the confidence interval? Oh, it would decrease. Because the more people you have in a population,
the more accurate it's going to be.
Yeah, the bigger your sample size is, the more accurate it's going to be exactly.
Right. Okay.
So what would happen to the width of the confidence interval? Let me go grab some some chargers just so in case things turn off.
Right. Oh, that's fine.
How do you find the charger to the calculator?
Why is it you find it and then you always lose it? You used it last week.
Is it this?
It's a gray one. No, it's a gray cord.
This one?
Yeah.
I think it's this one. Wait, I don't know if this one fits. Oh, it does. Is it charging? Yeah, it's charging. Okay. Question 10. What would happen to the width of the confidence interval if Gina changed it to 99% confidence?
It would also decrease, right?
The width, I think it increases.
It would increase?
Yeah. So the more confident you're going to become with the preciseness of it, the bigger the sample size you're going to need to show that it's that confident, if that makes sense.
So what is the width of the confidence interval?
It's the sample size, basically. How big of a sample size you need.
Oh, okay.
So the more confident you're going to be, the bigger sample size you're going to need to have, basically.
Okay, I was thinking it was the gap between the high and the low.
No.
Okay.
Unless if I'm doing it wrong, that's a total possibility too.
You're probably doing it right. I said I really don't understand this chapter or this section.
Brightbulb Light Bulb Company is planning a study to assess the average life expectancy of their light bulbs. They know the standard deviation is 400 hours. They want a 95% confidence interval with a margin of error of 50 hours. What sample size do you need? So that was that last formula that I gave you.
Okay. Is that the m equals 2 standard deviation over n?
It's the only one with m in it, where you plug in the margin of error. Here, this one. This one.
Oh, okay. Yeah.
So we're solving for n. 95%, so that is 1.96 as the z value. And it gives us the standard deviation of 400 divided by m. So a margin of error of 50 hours, so 50 squared. Okay, I hope I do the order of operations right on this.
I'm trying to make sure the number is right.
400 divided by 50 is 8. And then I get 246.
Sorry, I'm almost there.
Take your time.
So I got 245.86.
Okay, but we're supposed to round to the nearest whole number.
Oh, okay. But I got 246.
Okay.
Oh, and you round up every time, right?
Yep.
Okay.
Because it's like an extra person that you'll need.
Right. Mean salary of actuaries is 100,000. Standard deviation is 36,730. You're interested to know if the mean salary for women actuaries is different from the population mean, but are not sure if it is higher or lower. You set up a hypothesis test with level of significance at 0.05. You collect a simple random sample. Let me see. What is the lower limit of this 95% confidence interval? So that's the first formula, right?
Yeah.
So that's the mean minus the z-score times.
So you'll just need the first half of that equation. You see how there's that comma there?
Right. So it'll just be the mean minus the z-score times the standard deviation over the square root of the sample size.
Yeah, exactly.
Okay.
I kind of zoned out. Is there any trickery, or can you just plug the numbers in?
It seems like there's a lot of information. Like that's what kind of was, to me, that was like the trickery, but.
Okay, the mean salary of actuaries is 100,000. The standard deviation is 36,000. You are interested to know if the mean salary for women actuaries is different from the population mean, but you are not sure if it is higher or lower. You set up a hypothesis test with the level of significance of alpha equals 0.05. and the null hypothesis of 100,000. You collect a sample random size of 36 women's salaries and find that the mean is equivalent to 111,000. Okay, it's just plugging in. So 111,000 minus 95% confidence, that is 1.96. Times the standard deviation of 36,730 over, it's a sample size of 36, so the square root of 36. $36730 divided by the square root of 36.
All right, I did this wrong.
61216667.
I got like 679 million, so that's obviously messed it up somewhere.
Just get the lower limit.
Oh, I see where
I got $99,001.
Yeah, I did the order of operation bad. Let me try it again.
Wait, can't you just plug in the mean and then minus the variance from it? Do they give us the mean?
Yeah, the mean is the 111,000. So I think you wanna.
But that's not the confidence interval, is it?
And so I think you get the 6121.667. And you times that by the z-score.
Yeah, so I got an answer of $99,001. Go up, try it again and see if we get the same answer. If not, we can try it again.
Okay.
Double check.
And for this one, we use the mean minus the. Right, we don't do the mean plus.
Yep.
Yeah, I got $99,001.59.
Does that seem like a right answer though?
Let me see. Yeah.
All right, so round up to 2.
Yeah.
What is the upper limit?
Wait, I don't know if I'm. Is it so? The lower limit, that's like, if you have between two limits, is going to be 95% confidence, right? So, essentially between this number and then the number above it, it's going to be 111,000, right?
Yeah.
Okay.
I got my answer when you're ready.
For number 13,
Yeah.
I got 122,998.
Yeah, that's what I got. There are 3 requirements that need to be checked when computing a confidence interval for a mean. They are I would just assume all of the above, right? Yeah, all of the above.
Yeah, that's all I'd say.
Okay, I'm feeling not so confident in this.
Well, we'll find out in a second, huh?
Yeah. Like very unconfident.
I feel okay about it. So I just submitted it, and yeah, we got them all.
100%?
Yeah,
You serious?
yeah. And some of them are only worth like half a point, so I saw a lot of zeros on there, but it's just like 0.5 out of 0.5.
Dude, I thought we were going to miss 3 or 4 of them.
Looks like you know what you're doing.
No, I don't feel like I do.
Because I was sure lost, but
Do you
I
need
feel
help
like
with anything else?
no, I feel like these group meetings help out a lot, like these doing the group quizzes together.
But is there anything else that I can help you with? Anything that's not very clear?
No, I think I understand it. It's just figuring out what formula you use for each one.
Yeah, that can be a little tricky. Do you have the names written next to them?
I don't have the names written next to them.
Yeah, I'll tell you the names, so that'll make it easier. Okay, so you got the one with the comma, right?
The first
The
one
with the comma?
with the what?
Look for the one that has the comma. The upper boundaries and the lower boundaries.
Right, and that's the confidence interval, right?
Yes, confidence interval formula.
Okay. And then I know the sample size formula.
Sample size required formula. You got that
Right,
one?
that's one at the bottom. And then the other one's just the margin of error.
Yeah. This one right here is the margin. Oh, you can't see, can you? That's the margin of error.
Okay, yeah. That's what I thought. All right.
Well, thanks for live streaming it.
Yeah, no problem.
Do you mind writing my name that I was present?
Yeah, I'll go ahead and take out a comment that you were there.
Okay, perfect. I appreciate it.
Yeah, no problem.
Meet tomorrow, don't we?
Yeah, I think so.
Okay, hopefully we'll get a couple more people in now.
Yeah.
Okay, have a good night. Thank you.
Hey, you too.
Bye.
Good tomorrow.